In this lesson, we're going to talk about gas service. Annual maintenance is important to a furnace operation and customer comfort and safety. Be careful. During the inspection, power to the units must be shut off for your own safety. What you want to do, check the fresh air grills and louvers. Make sure everything is open and unobstructed to provide combustion air. Burners should be inspected for rust, dirt, and signs of wear. The vent pipe must be inspected for rust or sagging, dirt, signs of water, and damage or any disconnected joints. The unit should be inspected for rust, dirt, signs of water, and burned or damaged wires or components. The blower access door should be in place and provide a seal between the return air and the room in which the furnace is installed. The return air duct must be properly attached and provide an air seal to the unit. With the system running and operating, check the performance of the unit and vent system. The flue product should be analyzed and compared to the unit specifications. Upon completion of any furnace inspection, remind the customer to shut the unit off and notify a service company or technician immediately if any of these following are noted: new and unfamiliar sounds while the unit is operating, any unusual odors, unusual amounts of moisture in the heated space, or visibly burned components, or unusual dirt or rust accumulation of the vent pipe or unit. If any flu-like symptoms that subside when inhabitants are away from the house, this may be indicate carbon monoxide poisoning. What you need to have to service an equipment: you should have an inclined manometer, 0 to 3 inch range, to measure heat exchanger pressure drop. You should have another manometer, 0 to 1 inch range, to measure duct static pressure. You should have a U-tube manometer to measure gas pressures. You should have a volt and ohm meter. You need to have a microamp meter to flame sense rectification signals. You must have a thermometer or temperature sensor to measure air temperatures. You should have a snake for plumbing and drain tube cleaning, and you should have a small inspection mirror. What you want to do is you want to check the general condition of the furnace and the surrounding areas. Things that can cause problems include lack of combustion air, improperly sized vents, poorly or non-functioning air filters, or electrical shorts due to a water leak in evaporator coils or humidifiers. Check the obvious first. Look for blown fuses or tripped circuit breakers. Find loose wires or connections. Look for burned components and open safety switches and circuits. Check the manufacturer's instructions. Observe sequence of operation. Confirm correct wiring, and check self-tests and fault code LED functions. You want to visually check all electrical components for loose or defective wires. Make sure electrical power is available at the furnace by checking the circuit breaker position. Check the disconnect switch at the furnace to be sure it is in the correct position. Check that the blower door is secure, and if standing ignition is used, check that the pilot light is on. Check the condition of the air filter. Check the condition adjustments of the fan belt. Check for any accumulation of dust or dirt on the blower motor and cage. Start the furnace operation by placing the thermostat in the heat demand setting. Observe the burner startup and during operation. Observe the fan motor startup. Allow the furnace operating to cycle for about 10 minutes. Check the airflow through the room registers. Turn the thermostat to a lower setting to stop the burner operation, and check that the burner flames are off and the pilot remains on if it's a standing pilot system. Listen carefully to determine if the blower shuts off shortly after the burner flames are extinguished. Check exhaust for carbon monoxide levels, and always refer to the manufacturer's manuals. To troubleshoot ignition systems, they are controlled by a solid-state ignition control module. The module sends messages to and receives messages from other components within the ignition system. The difference between direct spark and hot surface ignition is that the direct spark requires a pilot light established prior to main burner operation. The hot surface has no open flame for ignition. On need for heat, the thermostat informs the control module. The control module performs a self-check, and if the module senses a problem externally or internally, it responds by flashing an indicator light. The control module checks for closed limit contacts on the pressure switches and for normally open contacts. The indicator light will tell you a little bit about where the problem is, but it will not tell you what has caused the problem. All it does is tell you what sensor is locking out or showing a problem. The induced draft motor starts and purges the system for 30 seconds. After pre-purge, the igniter becomes energized for about 17 seconds prior to the gas valve opening. When the gas valve is energized, the gas flows to the burner and the heated igniter. This gas is ignited. The igniter becomes de-energized 4 seconds after the gas valve is energized, and through the flame sensor, the control module must detect the main burner operation within 7 seconds or it will de-energize. After the burner flames are sensed, the fan blower motor is energized. This occurs through a time delay within the control module. When the thermostat is satisfied, the gas valve is de-energized along with the induced draft blower. An adjustable delay to fan off sequence begins to de-energize the fan blower. The chart 1, it is out of your book, and it is a way you use the flow charts if there's any to and you can find most of these in manufacturer's directions as well. Use flow charts to verify you're doing the proper sequence of operation for diagnosing. On a direct spark ignition system, the thermostat calls for heat, the relay control is energized and produces a voltage spark. The main gas valve is energized, allowing gas to flow to the pressure switch and pilot orifice. The flame is proven by an electronic flame sensor. If the flame is proved, the furnace continues operating. When the thermostat is satisfied, it de-energizes the ignition system. The pilot goes out until the next thermostat calls for heat. Again, you have flow charts available in most operation manuals and service procedures. Make sure you use them. To troubleshoot furnaces, you can use the flame. Proper startup and operation of a furnace requires the correct fuel-air mixtures, gas pressures, and flames. Primary air promotes complete combustion. The amount of primary air entering the burner is controlled by adjusting a shutter. If no shutter is present, refer to the manufacturer's literature on how to adjust the primary air. The proper flame has a soft blue color without yellow tipping or lifting. The flame should not flash back, pop, float, or roll out. If you have a yellow flame, it's a lack of primary air. To fix it, reset primary air or check for blockage. Lifting flames, gas velocity is faster than the speed the gas can burn. Reduce the input gas or primary air. Popping noises is flashback during shutoff and burning continued. Increase gas pressure, reduce primary air, reduce orifice, check gas valve and burner. Floating flames are very dangerous. It includes incomplete combustion and it causes release of carbon monoxide. Check gas flow, primary air components dealing with secondary air, and check flues and burners. Rollout is very dangerous as well. It's a blocked flue or poor draft. Might be incomplete air supply or burner overfiring. Check the gas flow, flues, burner, and secondary air sources and primary air.